Right, yeah, so RESTful approach makes development of modern web apps much more flexible and maintainable. The new tendency is to build...
Tonyfa3 says, "Oh cool, this is a fantastic setup, API GW to Lambda."
Oh yeah. So yeah, the new tendency is to build more complex clients with client-side frameworks such as Angular, React, Polymer, and this way your web app can be easily distributed as a set of static assets, HTML, JavaScript and CSS files. This will load dynamic content via an API. This new architectural pattern allows you to separate business logic from your presentation layer. At the same time, your clients will be easier to scale and reuse eventually by more than one client, including mobile apps. In the AWS world, a typical configuration would look similar to the following. You have a static website hosted on S3, distributed via CloudFront, and then RESTful APIs implemented with Lambda and HTTP endpoints exposed by the API gateway. Dynamic data stored in DynamoDB, RDS, or another database is another alternative. This is how you'd have built a completely serverless web application, meaning that you don't need to manage, patch, or maintain any server during development. What is REST? REST stands for Representational State Transfer. Is meant to be an architectural reference for developing modern and user-friendly web services. Instead of defining custom methods such as and protocols such as SOAP, WSDL REST is based on HTTP as a transport protocol. HTTP is used to exchange textual representations of web resources across different systems using predefined methods such as get, post, put, patch, delete. Standard representation is JSON, which is also the most convenient format to develop a modern web app, since it's natively supported by JavaScript. The level of abstraction provided by a RESTful API should guarantee a uniform interface and a set of stateless interactions. This means that the information necessary to progress and request must be included in the request itself. Within the URL headers or the query string or body. Furthermore, each resource should eventually be cacheable by the client based on a particular use case. So what's next? With Amazon API Gateway, we'll define the resources, map them to a custom model, specify which methods are available, and eventually bind each method to a particular Lambda function. Alternatively, you can attach more than one method to a single Lambda function. This way you'll maintain fewer functions and partially avoid the cold start Lambda issue. In the next step, we'll learn how to create the new resources endpoints and how to implement serverless. Right, let's do that. Alright, during the lab we'll be given a simple API to read a full list of items and details. It's gone off the edge of the screen. And details given by an item by ID. Therefore we'll need to define two endpoints, one for items and one for items/ID. The roots are compliant with the RESTful design principle, and the first endpoint lets you retrieve the full list of items. The second one will retrieve a single item given for an ID that you provide. As you'll notice, the second root is defined in terms of dynamic parameter, which is part of the URL itself, and of course you could achieve the same result with a query string, but this pattern is generally discouraged. In order to keep your data structure well defined in your interface documented and maintainable, you'll create a new API gateway model. Models are useful to map the API endpoint payload via mapping templates. They're not strictly required, as you can manually define your mapping template. Having a model will let you generate strongly typed SDKs for your API resources and better validate your payloads. Technically, you can define a model with the JSON schema. For the lab, you'll define this simple model, and they've provided me with a model. Our items will have unique numeric IDs, string identifying its name, and a numeric price. This could be an overly simplified model for a sample e-commerce application. In this lab, we're going to create the API in API Gateway, define the model explained above. We're going to create the associated API resources and methods and then deploy the API. So we need to go to API Gateway. So Right, then we've got pick a type. In this case, it would be REST. So I'm going to build. Right, and then it's given me, so API name is items API. And then endpoint regional, yeah. API. So now the API will be created and we can define a model for it. They got stuff in there. Click API, items API. There we go. Right, so it already gone into it. So items API, and then models, and then we'll create a model, and then the model is going to be item, content type, application JSON, and then we need this schema. So the item is an object, and it's got the properties of ID, name, and price, as it said earlier. Right, so the new item model is listed under the models, so we actually have to create it, and then there we go. Now we'll create another model with a list of items with the following values, so we need to create another one. And this one will be items JSON, and then it's basically the same. So items array this time, and then we need the API ID there. So note you'll need to replace your API ID in the items JSON above with the actual API ID. You can find your API ID within the breadcrumb trail of the API Gateway console. So we can copy that. Let's just take the brackets off. So you should now see both items and both item and items beneath models in the left navigation. So we need to create that. Right. So now if we click on where is it we've got to go? Click on resources, and then create a resource. In the new child resource form, enter the following so that we can create the resource. We're going to use proxy leave unchecked, resource path root, source name is items, and then leave cause unchecked because we don't care. So there we go. So now we've got an items resource. It should be selected in the resources panel. Notice that there are no methods created yet. We're going to create a get method to retrieve the list of items. We create a method, and we're going to mock. So the mock integration allows you to define the API resources and methods whenever we don't have an actual backend implemented yet. The advantage of this is that you can now use the items model previously created to generate fake data. For example, this would allow you to provide a temporary API endpoint for your front-end mobile developer even before you've actually had a real implementation. In the method execution diagram, click on integration response. So we don't even need that, we can just mock get. So integration response, there we go. Right, so we need to edit the response. Expand mapping templates. Select items. It's given us the template. We need to override the generated template with the following code, which will generate a list of 3 item objects. So we'll get rid of that. So for each ID in 1, 2, 3, generate a random price. It's not really random, but be 1 times 1.5, 2 times 1.5, 3 times 1.5. Create a name. Cool, and then save. We're redirected back to the resources page. From the resources page, select the test tab. Test. Right, so we can just run the test. We don't need the params. And there we go. So we get the generated template back. This method will return the template that we defined. You will now define an API resource for individual items on the ID path. Scroll to the top of the resources page. Click on Create a Resource. And then this time, rather than items, resource name will be the ID param. Everything else unchecked. We only need to insert the ID part of the path since items is automatically added when creating the new resource. With items selected in the resource panel, this means that the item resource is a child of the items resource. The ID path variable makes the path dynamic. This way the API gateway will treat any value as a dynamic ID and it will pass it into the backend implementation, which will return the corresponding data. So if we need to create another mock, so create a method again, and get and mock. And integration response, edit, and what do we want for this one? Template, generate template, item, and then we're replacing that with this, so we can generate a random ID. The template will extract the dynamic ID, cast it to integer, return an item object with a generated data. If we test this ID, this time we'll have to provide the ID, so we'll say like 10 test, and it will generate the example response. So if we leave the ID blank, we'll get an internal server error. Any integer value would return a valid JSON. If we replace the simple mock implementation with a real implementation in the following lab steps, for now we can proceed to deploy the API with the mock backends. So we can go to the top, click on Deploy API, select New Stage, stage name dev, give it a description, and then deploy. Right, the API is now deployed and it will be ready to serve requests from the items and item ID endpoint within the dev staging environment. You may see a warning notification if your user does not have the list web ACL and associate web ACL permission for the WAF file, regional file. Use of the web application file was not required for the lab. You may see this warning several times during the lab. The warning can be ignored. Repeat the deploy API action from the resources panel again, this time creating the prod stage. So go back to APIs, item API, deploy API, new stage, and then this time we want prod. And I'm going to copy the Right, so in this lab step we have deployed an API gateway API into the dev and prod stages by creating a model, creating the API resources, creating API resource methods using mock backend, and we've deployed it to both dev and prod stages. So I need to do the little check. So did it work? It did. Nice. So now we can progress to the next step. Right, so we've designed and created the API gateway resource in the previous step. It doesn't have a real implementation yet, so in this lab step we'll create a new Lambda function that will handle both endpoints. The approach has the advantage of reducing the number of functions it will need to maintain, therefore the amount of code, and besides partially solving the cold start issue of Lambda, the cold start issue with Lambda is due to the initial startup phase of your function code, which might take a few seconds. Having fewer functions, you'll increase the likelihood of keeping them warm even if they don't have a very high load. Lambda functions that we'll create will dynamically check whether the item ID or the entire list has been requested and behave accordingly. Since we've already created an API, we'll not use the simple flow to create the new Lambda backend. This flow is recommended whenever you start from scratch with Lambda. You don't need much of the API gateway configuration. This is the norm in most simple use cases. So this time we need to go over to Lambda. And we need to create a function. In the author from scratch form, so author from scratch, item name is, function name is items function, runtime will be Python, function name needs to be named items function, otherwise you won't be able to proceed. That's fine. We need to assign an IAM role. So we should change the default. Use existing role. We've got a role, Lambda basic execution. We've selected the role that's been created for us. The role is necessary to requires the IAM permission needed to complete the lab. Scroll to the bottom and create the function. Scroll down to the source code section, double click the Lambda function py file and overwrite the content with the following. So replacing all of it. So that's acting as our database. Alright, so source code will look like this. The function is very simple without specific dependency or infrastructure requirement. The logic is straightforward. If no ID is given, it gives you the whole list. If an ID exists, it will give the specific item. Otherwise, it raises an error. The other AWS Lambda configuration fields are left with the default. Deploy the function at the top of the source code, click deploy. Then we get we've updated the function. You can now test the function. Create a new event. Event name, get items. Event body. Just a blank JSON. Save it. Right, now we can run get items. There we go, so we get the full list. Repeat the test process to test 2 more code paths for the following use cases. So we need to test for so if the object has ID 1, create a new event, get item ID 1. Test, get number 1, and then we need another one. Create a new event, ID 5, and then this one will be 5. Because 5 isn't in the list, it should fail, so now we get the error. Brilliant. Note in the real world scenario you would have to perform these operations on a database. In the simple example, we've got a static list of objects in the main memory, more than enough. Also keep in mind that the code will run multiple machines, containers, and will not be able to update the in-memory list consistently. In fact, only get methods are defined and no transformations on the items have been allowed. In this lab step, we created and tested the Lambda function that will serve as the backend for the API. Within the API gateway, before we can use it, it's best to understand versioning so that we can use different versions of the function in the dev and stage environments. In the next lab step, we'll show you how to work with functions, function versions. There we go. Right, in this lab step, we're going to create different versions of the Lambda function corresponding with dev and prod. Each Lambda function has a default latest version variable, which is one that we can always work on and edit. Once your code is stable enough, or whether your code changes significantly, you can create a new version. A simple incremental number will be assigned to the new version, and you'll be able to use and test any version. As you can imagine, this is a useful mechanism to keep track of your function history and eventually roll back to previous versions. Using versions is helpful, but sometimes it's not flexible enough. For example, you can only bind the API gateway resources and methods to a specific version of the function. Whenever you create a new Lambda version, you'll need to update the API gateway configuration as well. Fortunately, AWS provides the concept of an alias to improve the situation. An alias is a useful abstraction that allows you to refer to a function version without actually using the version number. For example, you may want to create prod alias, connect it to your API gateway production stage. You could do the same with a dev alias and bound it to your development stage. The best practice would be to always reference an alias when configuring the API gateway backend. By default, the API gateway will point to the latest version, but you can always configure it to use a specific or an alias. The following is an example of how the version and alias mappings work. So items function will point to latest version, items function 1 will point to version 1, item function prod will point to prod. You can now create the new version and the 2 new aliases for the Lambda function. In the Lambda console, click on the version tab. And then we need to publish a new version. Where is that? Oh, there. Right, a new form will open allowing you to specify the version description, which apparently we don't need to do. Please note that you cannot modify a published version, you can only work on the latest version. So next we'll create the alias lambda. So that's latest, we need to publish that. Right, at the top right, click on Action. Create the alias. We need to create dev, development alias, version will be latest. So we're now creating an alias for the dev stage. The dev stage will always work with the latest version of the function. By binding the dev alias to the latest version, you'll be able to quickly implement changes and test them without explicitly publishing a new version. Of course, you can always adapt this configuration to your own needs. You usually won't want to be so aggressive in the automatically releasing latest function to production. Your alias to prod will use a specific version instead. To save the alias and return the function detail, click Save, and then at the top, click Item Function. To create the alias for prod, at the top click Actions, Create Alias, and then this one will use prod alias, and then version is the 6th one that we published. So we'll save that. Note the weighted alias option. This is traffic to an AWS Lambda function that can be split between multiple versions. This will allow you to test a new version of the function on a subset of traffic before fully deploying it. Weighted aliases won't be used in this tab, in this lab, sorry. To save your alias and return to the function detail, click Save, and then at the top click on Item Function. To see the aliases that you have created, click on the Aliases tab. There we go, and then you'll see both dev and prod listed. You can also see the version and the version that you have published by clicking on the Versions tab. Now that the Lambda function is configured with the version and the aliases, we can use it within the API Gateway backend. In the next step, we'll properly configure the API Gateway to use the new Lambda functions and the aliases. So we will, in this lab step, we're going to update the API Gateway, turn off the mocks, and then get it to use Lambda. This will map both the API endpoints to both the same Lambda function. So we need to return to API Gateway. Items API, and we want to go into the items get method. Click on the integration request, and we need to edit the following. So take it off mock, put it on Lambda. We're going to use, that's going to be unchecked. Keep it on WES2. And then we're going to say item function is, that one's already listed. Remember that when you simply select the Lambda function name, the API Gateway will use latest version. Using latest is not recommended since you'll always want to bind your API resources to a stable Lambda alias. The next instruction will show you how to map each API Gateway stage to the correct Lambda alias. to use the dev alias, add a dev to the end of the Lambda function. So we need to do colon dev. Then we hit save. To update the alias of the Lambda function, click edit in the integration request setting and change dev. Do we need to deploy that? No, I don't think so. It's just getting us to change it. We click on that again, we edit it again, we go down here, we change dev to prod. Then we save it again. We'll now do similar actions with the items ID resource. So for this one we go to the information request, edit it, put it on Lambda, leave that unchecked, use the Lambda function. Lambda function will be using dev. So we don't need to pass through where no template is defined. Right, so this time we'll need to configure the mapping template because the resource includes the dynamic ID. You will map the ID path parameter to the Lambda event parameter via a custom mapping. So we scroll down to mapping template. We use JSON, generate a template from items. Right. Copy code. Save the changes. And then to update the alias of the Lambda function, click edit in the integration request. So we've got to do that again. Prod. Save. Right, there we go. So at this point, API Gateway resources can access both Lambda aliases. We won't need to manually grant any additional permission. You'll now need to redeploy the API into the prod stage. Click on Deploy API, prod stage. If everything goes fine, the same endpoint will finally return real data instead of the fake data. So we'll deploy it. Right. In theory, you need to deploy the dev configured resources into the dev stage and the prod resources configured into the prod configured resources into the prod stage. For now, you can just deploy the same configuration into both stages, both dev and prod, since you'll completely change the backend in the next step. To make it more dynamic and flexible, click on the API deploy and select the dev stage. So we're just going to redeploy it essentially. Into dev, even though we didn't do anything. Remember that we can test the API integration in the console before deploying it. Return to the method execution and click test. So now we get the actual data. That's not right, is it? It should be the other one. Yeah, why are we getting more than one? Let's have a look. What did the request have? Did I not add the mapping? Invalid patch path request template. Yeah, that definitely didn't work as an integration. And there's no template defined, that should be that. That's better. Right. I don't think it applied my logic before. 3, 4, 5. Let me get the error. Nice. That's what it should have done. And then. Right, so in this lab step, we've configured the API integration using the Lambda function. You deployed, and you've updated the API to both dev and prod. Yes. Well, I've probably got to deploy it again actually now. Let's do it to prod. Too many requests. Right, so that's redeployed. We can next step. Right, so we have previously created Lambda function. We versioned it. We've got aliases for those functions. And we've got the API gateway, both dev and prod stage, and we've got the resources configured. Both API endpoints are attached to the same Lambda function. They currently use version 1. This configuration is not very robust. It doesn't allow you to update your Lambda function and see the updates in your dev. The recommendation best practice is connecting the gateway stages to the corresponding Lambda alias so you can easily manage new functions. We can achieve this by creating a new stage variable, and then we'll use this variable as a Lambda alias in your gateway backend configuration. Stage variables can be used to configure the request integration of your resources so that you don't have to modify them every time that we want to redeploy your API. So in the stages, dev stage, click on the stage variables, add a stage variable, manage, enter the following values. So we want Lambda alias dev, and then in prod we want to add the same Lambda alias but with prod as the value. We can now update the API gateway resources configuration to use the stage variable for both the items get method and items ID get method. Modify the integration request to item function stage variable Lambda alias. So we go back to resources. Integration request. So the Lambda function needs to be since Lambda aliases are now dynamically configured in the API gateway stage, you would normally have to manually grant the API gateway permission to invoke dev and prod Lambda function aliases. The API gateway will warn you about this. You can grant permission to the AWS CLI with the AWS CLI. For the lab, we don't need to grant any additional permission because we've already been granted the gateway access to dev and prod aliases. Right, so we need to save that. We can now redeploy it to your dev and prod stages using deploy API. So dev, deploy. Deploy, prod. It's using the Lambda alias, good. Right, so now we can test the API. You can no longer use the test button in the method execution diagram because the method now depends on being executed in the context of a specific stage. Click on stages, prod, and copy the invocation URL. Paste the invocation URL into a new tab and append items to the end. There we go. Now we'll get the list of items returned confirming that the stage variable for the prod is configured correctly. In this lab step, you've configured the stage variables to the reference of the Lambda function used for the API gateway backend integration. Now the API gateway is correctly configured, and you're free to update the Lambda function code to play with its alias mapping without coming back to the gateway. Right, API resources are still open, meaning that no authorization is required. Usually you'll need to secure the API and eventually have a more granular way to restrict the access. In this lab step, we'll use you will see the most basic authorization method via an API key. This is managed by AWS. Please note that the API key is intended to track API consumers and define custom throttling and rate limiting. In the API gateway console, you can create and import API keys and associate them with your API gateway stages. AWS also offers the concept of a usage plan, which will allow you to manage throttling and quotas in a more granular way. Technically, each API key must be bound to one or more usage plans, which can be bound to one or more API stages. This way that you'll have control and monitor each API key's usage and cluster similar keys together based on your own needs. In the API Gateway console under Items API, select the usage plan in the left navigation and create a new usage plan. So I need to go to... We're in Gateway console. Under Items API, find the usage ID. Where do we have that? Usage plan, there it is. Right, so we're going to create a new usage plan. It's going to be called that. Have that description. No throttling. No quota. We'll enable throttling and a quota in the later stages, so we'll create that. Click on the newly created usage plan and select the Associated Stages tab. There we go. Right. Add an API stage. Right, in most situations you would create a different plan for each stage so that you can have independent API keys with the scope of the lab. You can simply bind both stages to the same usage plan. Select the Associated API Key tab and click on an Add API Key. So, get my API. Stage dev. Add to usage plan. Let's get add stage again. Prod, add stage. Select the associated API key and add an API key. Create a new key. Lab key. Generate a key automatically. Once the API key has been created, it is bound to two API gateway stages in the usage plan. In the list, click on Lab Key, click on Show next to the API key to reveal the API key. Make a note of the API key and we'll use this key as a custom header later on. Let's just copy it. Right, for both the items and items ID get methods, click method request, edit in the diagram. So we need to go back into API, items, method request. We need an API key. And we'll save it. And that one. Need an API key. Save. Then we'll redeploy to both stages. You won't be able to simply get the resource in the browser anymore in that case, since the endpoint isn't open anymore. You'll receive a message forbidden response. So we need to deploy, deploy prod. Alright, then refresh. Hasn't done it yet then. No, it didn't work. Yeah, it's definitely API key required. There we go, it's finally working up. Right, so we get the forbidden. Optional, if you have a system with the curl command available, you can send an authenticated request using the following. I've got curl installed on here. Dude, nice. I didn't like that. Maybe just capital H, maybe? That's better. There we go. Note, if you don't have the curl command available, you can use a web-based curl site to test the command. Search the web for web-based curl to find one. You can create up to 500 API keys and 300 usage plans per account. This means that you can't associate one unique API key to each user of your application. API keys are more suitable for server-to-server scenarios or third-party customers. Alternatively, you can secure API gateway with your own custom IAM rules or with a custom Lambda authorizer. The limits of the API gateway services are published by AWS in the developer guide. Many limits can be increased by contacting AWS support. In this lab, we created a usage plan, associated it with the API stages, and then we created an associated API key and the usage plan and required API keys to access the API. So we need to run the tests. So start my checks. Did we create a usage plan? We did. That's good. Alright, next. Right, enabling calls. There we go. Some actual security. CORS stands for Cross-Origin Resource Sharing. It's a set of standard HTTP headers used to restrict the access of the web resources from other domains. In the web app security model, this is called the same origin policy, and it's supposed to avoid cross-site scripting attacks. Browsers will not fetch the requested resources unless the corresponding server attaches the required HTTP header in the options call or the get method. The API gateway will not automatically add these headers, but it provides very useful friendly wizard. In this lab step, you'll see how to enable CORS on our API gateway resources. Keep in mind that you'll need to enable it on each resource. Select the items API resource and click on enable CORS. Is that the right bit, or is it? Okay, it's actually that bit. So enable CORS. This will start the wizard that allows you to configure which heading to serve and which headers are allowed. Minimal CORS integration would require at least the access control allow origin header. If its value is star, every domain will be allowed to fetch this resource. The API gateway will automatically allow get and options methods, plus all the default headers used by AWS services. This will guarantee that you can use API keys, basic auth, and IAM tokens. Select get under the access control allow methods. Leave all the remaining values default and click save. Note that there is not too much magic going on here. The API gateway will simply configure itself to enable calls on the specified resource by creating new options methods and the required method response. Repeat the above instruction for the ID, enable CORS, get, save. Right, so in this lab step, if you've used the API Gateway Wizard to enable CORS, both of the API resources, CORS will enhance the security of the web app. Right now we can enable API Gateway caching and throttling. You can configure the throttling and caching independently for each API Gateway stage. For example, you may want to avoid throttling and caching on the dev stage and enable them on the prod stage. Please note that although throttling is 3, caching is provided by a custom instance whose size and cost depend on the selected cache capacity. From 500 meg to 237 gigabytes. Optionally, you can encrypt your cache data and set a time to live in seconds to require authorization for cache invalidation requests. You can configure caching and throttling for the prod stage in this lab step. Select the prod stage. Right, click on Edit in the stage details. Toggle on Provision API cache. Cache capacity is 0.5. Encrypt the cache. Time to live, an hour. Require auth. And unauthorized will fail the request. The throttling, enable throttling, 10,000 requests, 5,000 requests, and then save. In case you have special customers and you want to limit their access to your API, you can configure the throttling and daily, weekly, monthly quota on the corresponding usage plan. Select usage plan. Academy plan, action, edit usage, and toggle quota. If the quota exceeds 1,000 requests per day, This configuration will ensure that each individual user, as identified by their unique API key, they won't consume your stage or account capacity. Of course, you can monitor and update these configurations at any time, even after creating the usage plan or an API key. So we'll limit that. In this lab step, we have enabled caching and throttling on the prod stage. We've also enabled a quota at this usage plan level to limit the number of requests authorized by an API key per day. Alright, cleaning up any API resources and Lambda functions. As a final step, you will delete all the resources created in the lab. Delete the following resources in the given order to avoid any conflicts. We need to go to API key, delete the lab key, delete, yeah. Go to stages. We need to delete dev and prod. Delete prod. Usage plan. API resource. The API, confirm. And get rid of all that. And then go to Lambda. And delete the function. Please note that you won't be able to delete usage plan if at least one API stage is bound to it. This is why you need to delete the stages first. Alternatively, you can just delete the API altogether. With its stages, you'll need to confirm the API name in order to delete every API resource, model, stage, and stage variable, etc. By deleting the Lambda function, you'll also delete all the related versions and aliases. Interestingly, you could also delete the Lambda function first, and the AWS console will not complain, although the API gateway will still not have a backend anymore, and your API will return a 500 internal server error. Congratulations, you've created, configured, and destroyed your first serverless API. So we've got one more check. So did I actually delete them? And I have. So that is done. Submit.